Hello and welcome to the sixth lecture of refrigeration and air conditioning. The lecture that we are going to study in is the topic of cooling and heating coils. What happens that in the air conditioning when the air has to be cooled down, or in the winter air conditioning when the air has to be heated up, the cooling coils or heating coils are used, over which the atmospheric air flows over, so that the required cooling can be attained. Therefore, it is used for the cooling and heating of ventilation of air. It is used for cooling and heating of ventilation air. Now, cooling of air in air conditioning system, there is a cooling coil. There is a cooling coil which is at certain temperature called TC, that is temperature of cooling coil. Temperature of cooling coil. Over this, an air with initial temperature T1 is flown over, and while flowing over the coil, the air comes in contact with the coil and gets cooled down. It is to be noted that the temperature of the cooling coil is smaller than the temperature of T1, temperature of inlet air, that is T1. Now let us consider that 1 kg of ventilation air flows over a cooling coil. Now what happens when air flows over cooling coil? Some of the air goes through the cooling coil, while a certain amount of air does not flows over the cooling coil, and it goes without touching the cooling coil, and this portion is bypass air. Let us say, out of the 1 kg of the air, x kg is bypassing, and it is not coming in contact with the cooling air, while the rest 1 minus x kg 1 minus x kg comes in contact with the cooling coil and cools down. When the temperature of the air, when the air flows over the cooling coil, it will cool down to the temperature Tc. 1 minus x kg of the air will cool down, while the remaining x kg of the air will remain at the same temperature. And after coming out of this air cooler, these airs will mix up again. 1 minus x kg of cooled air and x kg of uncooled air, they will mix up, and finally 1 kg of complete air will be available, but at a different temperature, and that temperature is T2. The temperature T2 is lower than T1, but it is higher than Tc. This process that is happening here is cooling and dehumidification process. If we see this process on psychrometric curve, if we see this process on psychrometric curve, then it will be something like this: point 1 to point 2, and this point that is touching on the saturation curve will be adiabatic apparatus dew point, and the temperature of apparatus dew point is TADP, and it is nothing equals to temperature of the coil that has been shown here with this in this diagram by the name Tc. Now if we look onto the diagram, there are two sections. One is when the air, how 1 minus x kg of air is touching the coil while the remaining is going. This section we consider as AA section, and another section is when the air have mixed, when the both two streams of the air has mixed and final air at temperature T2 has been achieved. This is section BB. Now writing the energy balance equation for the two sections. Writing the energy balance equation for the two sections, we will get that 1 minus x kg of 1 minus x kg of air that is coming in contact with the coil will come at temperature Tc, and its enthalpy will be represented by Hc, while x kg of the air that has not come in contact with the cooling coil will be at the initial temperature T1, and its enthalpy will remain H1. This should be equals to the complete enthalpy of the complete air after mixing, that is 1 kg of the air with enthalpy H2, since it is at temperature T2. This is energy balance. This is energy balance equation. I will write it down. I will write this again, this equation again. I'm just writing it again. 1 minus x Hc plus x H1 1 into H2. We know that the enthalpy is a function of temperature only for air, which is an ideal gas. And here the mixture of, here in this case mixture of air plus water vapor is also we are considering ideal gas. Therefore the equation will become as 1 minus x Cp Tc plus x into Cp T1 is equals to Cp T2. Cancelling out the Cp, we will get 1 minus x Tc plus x T1 is equals to T2. If we solve this equation out, if we solve out this equation, we will get the value of x as T2 minus Tc upon T1 minus Tc. This very expression is known as the expression for bypass factor. Expression for bypass factor, and this x is called as bypass factor. It is nothing but, bypass factor is nothing but the amount of air that has not come in contact with the cooling oil and bypass the cooling coil and the bypass the process of cooling. This is bypass factor. Now if we want to calculate the efficiency of some cooling coil, if we want to calculate the efficiency of a cooling coil, then efficiency of cooling coil is considered as 1 minus bypass factor. 1 minus bypass factor. Putting the value of bypass factor, that is x, we will get the efficiency as T1 minus T2 upon T1 minus Tc, where Tc is the temperature of the cooling coil, T2 is the temperature of the air after coming out of the cooling device, where T1 is the temperature after before entering the cooling device. All the temperatures are dry bulb temperatures. Now if we draw the psychrometric chart and try to represent the above mentioned process, then psychrometric chart will be something like this. Corresponding reliable temperatures are T1 and T2. Corresponding specific humidities will be omega 1, omega 2. Now if we try to calculate the enthalpy at the point 1 and 2, this point is ADP and the temperature is TC. Corresponding specific humidity will be omega C. For calculating the enthalpy, we will draw a enthalpy scale that is actually there in the psychrometry chart, and the line passing through the point 1, point 2 and point C will, when match with the enthalpy scale, will give the value of enthalpy. Therefore, this value is H1, this is H2 and this is HC. Bypass factor can change the bypass factor in terms of temperature as T2 minus Tc upon T1 minus Tc. It can also be written as H2 minus Hc upon H1 minus Hc, and also it is approximately equals to omega 2 minus omega C upon omega 1 minus omega C, where omega is the specific humidity at state 1, 2 and C. Now if the multiple coils are used in series, there's not just one coil, multiple coils are used. In that case, we will be trying to calculate the equivalent bypass factor. What happens here? There are two coils connected in series. Two coils connected in series with bypass factor as X each. Bypass factor of each coil is X. X for each coil. Now let us consider 1 kg of air flows, and out of this 1 minus x kg will go to the cooling coil and x kg will go out. After coming out the first cooling coil, they again mixes together and approaches the cooling coil 2. While going the cooling coil 2, again out of this 1 minus x kg will go in the cooling coil, while the x kg will come out, and after coming of the second coil, again they will mix up and will be 1 kg again. That the initial temperature is T1, intermediate temperature is T2 and T3 is the final temperature. Now writing the energy balance equation for coil 1. Writing the energy balance equation for coil 1 will be 1 minus x kg of Tc are the temperature of the cooling coil. 1 minus x kg of Hc plus x kg of H1, that is equals to 1 kg of H2. This will come out to be 1 minus x kg of Tc plus x kg of T1, that is equals to T2. Considering this as equation 1. Now writing the energy balance equation for the second coil T2. Here 1 minus x kg of Hc plus x kg of T2 will be equals to 1 kg of T3. this is H2, this is also H3. Writing in terms of temperature, this is 1 minus x kg of Tc plus x kg of T2, it will be T3. This is equation number 2. The value of T2 in the equation in the equation 2 can be used from the equation number 1, and while putting the value, the above expression will term the equation the expression number 2 will become as 1 minus x Tc plus x multiplied by the value of T2, that is 1 minus x Tc plus x T1, and this should be equals to T3. Simplifying the above equation, the expression will come out as x square T1 plus 1 minus x square Tc is equals to T3. This is the expression for the joining the initial temperature T1, final temperature T3, and the temperature of the coil. Now, instead of using the two coils, if we use a single coil, if a single coil is used, which is equivalent to the above series of two coils, temperature of coil is Tc, inlet temperature T1, outlet temperature is T3, bypass factor is some Xe. Then in that case, the bypass factor is some Xe. Xe is the equivalent bypass factor to the above arrangement of two coils. Then in that case, the energy balance equation will be Xe into T1 plus Xe into T1 plus 1 minus Xe into Tc, that is equals to T3. If we compare the equation, this let us name it as equation number 4. If we compare the equation 4 with the previous equation 3, in which T1 and T3 were connected by the expression using the two coil system, then the these last two expressions will give the same result if the equivalent bypass factor of the equivalent coil system will be equals to x square. Hence, this Xc is the equivalent bypass factor in case of multiple coil system. If there were two coils, that is why is x square. If number of coils are n with x bypass factor of each coil, then Xe will be x to the power n, x to the power n. Moving on to the next topic is latent heat factor and sensible heat factor. Latent heat factor and sensible heat factor. What happens whenever such kind of cooling or heating is taking place in which there is a change in the driver temperature of the moist air as well as the specific humidity? In such cases, both sensible heating as well as latent heating of the air is taking place. So drawing such diagrams such process on the psychrometric chart. If this is some certain process 1 2 2 1 to 2, in which the temperature is changing from T1 to T2 and specific humidity is changing from omega 1 to omega 2, there is one more thing that can be understood while the process is happening, that is enthalpy. The enthalpy of the moist air at the initial temperature, the initial condition and final condition can be drawn as drawing the constant enthalpy line up to the enthalpy scale, and this is H1 and H2. Now what happens when the process is happening? The above process can be considered as a combination of two processes, the process 1 2 3, in which temperature is not changing, only the amount of water vapor that is present in the moist air is reducing. This process we can also consider as latent heat process, because in which the phase change of the water vapor is taking place. Remaining process 3 to 2 can be considered as the latent heating process, sensible heating process. This can be latent heating and sensible heating process, because during this process, at a constant uh, amount of water vapor present in the moist air, temperature is changing. So therefore this total heating can be considered as latent heating plus sensible heating. Latent heating and sensible heating. Now if we draw the enthalpy line at state 3, state 3 H3, so we can get that how much enthalpy change is taking place during the latent heating. Now writing the total heat exchange, we can write as H1 minus H2. Out of this latent heat, if we want to write, the latent heat can be considered as H1 minus H3, that is going from state 1 to state 3, and sensible heating can be considered as while going from state 3 to state 2, that is H3 minus H2. Now the ratio of sensible heat to the total heat is called as sensible heat factor. Sensible heat factor can be written as sensible heat to total heat, that is sensible heat upon sensible heat plus latent heat. This can be written as sensible heat, that is H3 minus H2 upon H1 minus H2. Similarly, latent heat factor can also be written. Latent heat factor can also be written. This is latent heat factor is the ratio of latent heat to the total heat, which is sum of latent heat plus sensible heat. Hence it is H1 minus H3 upon H1 minus H2. So these are the two factors, latent heat factor and sensible heat factor, that are important to study. Moving on to the next topic. Our next topic is air washers. Air washers are actually such devices in which water flows through air, or air is flown through a stream of water, in which the water mix up with the air, and the temperature and the humidity of the air keeps on varying. Depending upon the variation of the temperature and the humidity of the air, the following processes may be taken place by the saturated air. First is cooling, second is heating, third is humidification, fourth is dehumidification, then simply adiabatic saturation. The all which process will be taken place by the air will depend on the temperature of the water through which the air is passing. If the dehumidification of the air is taking place, then the makeup water will be provided. This is the simple schematic of the air washer, in which there are certain spray of the waters in which the air is through which the air is flowing. Here air enters from the left hand side and air goes out from the right hand side. There is a water tank. If there is a reduction in the if there is a reduction in the water in the tank, then the makeup water can be provided using a pump. Now looking on to the various processes that can happen in the air washers, we will see on the hygrometric chart. Let's say state 1 is certain state of a moist air, which is state of a moist air which is actually entering through the air washer. And now depending upon T1 is the trial temperature of the moist air, whereas T1 dash is the wet bulb temperature of the moist air, and TD, this is the dew point temperature of the moist air. Now the water temperature will decide through water temperature of the spray through which the air is flowing will decide what kind of process will take place. If the water temperature is greater than the T1, if the it is greater than T1, then process 1 to 2A will take place. This is heating and humidification process. Heating and humidification. If the water temperature is equals to T1, water temperature is equals to dry temperature of the air, then only humidification will take place. No sensible heating or cooling will happen. Therefore, the process will be 1 to 2B. Now, if the water temperature is less than the dry temperature of the moist air, but it is greater than the T1 dash, that is wet bulb temperature of the air. In such a case, cooling and humidification will take place. Cooling and humidification is happening, but the enthalpy amount will also increase. Instead of cooling of the air, since the air is getting cooled, but the amount of enthalpy will increase because of humidification of the air. Third, next process is if the wet bulb temperature is equals to the wet bulb temperature. If the temperature of the water is equal to the wet bulb temperature, in such case the process that will happen will be the constant enthalpy process, that is 1 to 2D. 1 to 2D is a constant enthalpy process. This is constant enthalpy process 1 to 2D, and in this process, during this process, adiabatic saturation will take place. The next process is 1 to 2E. During this process, the temperature of the water vapor will be lesser than the wet bulb, temperature of the stream of water will be lesser than the wet bulb temperature of the dry air, but it will be higher than the dew point temperature. The process, in that case, the process 1 to 2E will take place. This is cooling and humidification process. This is a cooling and humidification process, but during this process enthalpy will reduce. During the process 1 to 2F, the enthalpy is remaining constant, only dival temperature of the moist air is reducing. This process will take place when the wet bulb temperature, when the temperature of the water is equals to the dew point temperature of the moist air. There will be only sensible cooling. Now the last process is 1 to 2G. During this process, the wet bulb temperature of the water will be less than the temperature of the dew point temperature of the moist air. In such case, cooling and dehumidification will take place. So depending upon the temperature of the water and the temperature of the moist air, changing the temperature of the water of the spray through which the moist air is flowing, the process can be changed. All the these are all process which are 1 to 2A, 1 to 2B, 2C, 2D and 2E, and the remaining two processes are 2E, 1 to 2E and 2F and 2G. These are written over here, 1 to 2F and 2G. Therefore, we can say that mostly all kinds of process can take place through air washers. Hence, the air washers can be used for year-round cooling or year-round what we call it, year-round air conditioning. So that's all about the lecture number 6. In this we have studied 2-3 topics. In the next lecture we will talk about the comfort air conditioning and the human comfort. That's all for this lecture. Thank you.